So now that we know what a interface is, we can start talking about the Java's list interface, which is in java.util.list. Right, so that's how you would import it. So if you're a list, then the interface specifies all those functions you need in order to be considered a list. So some of the operations, which makes sense, we need to be able to get the value from a specific index, replace a value at a specific index, much like you can get a value from an array and put a value into an array, right, and replace it. But also, we want to be able to have a method that will find a value. We want to have a method that will add something to the beginning or the end of a list. And we also want to be able to remove something from either end of a list. In fact, scratch the whole beginning and end thing. We want to be able to add and remove basically any element to an arbitrary index, much like with our example with the peanut butter, how we could just put that in the middle. We can also put something at the head at the beginning of the list, and that's the new index 0. And then also provide us, and this gets into iterators, being able to go through the list without having to use mess with the indices. All right, so this is the basically family tree of lists. So we have list at the top, which is an interface, and then we have the abstract list, and that's extended by Arraylist and linked list and vector. And so Arraylist and linked list are the big things we're going over. Vector, we'll go over stacks in chapter 4, but Arraylist and linked list for right now. So an Arraylist extends the abstract list, and the abstract list implements the list interface. So what the heck is this abstract list? Well, it's an abstract class. It's what we were getting at. It's that mix between a regular class and an interface. An abstract class means that some of the methods it has are still stubs. Some of the stuff is just not done, but some of the stuff is done, and we can use that in the classes that do inherit us. Okay, so Arraylist is a fully fledged implementation of a list. Right, so let's go ahead and actually, now because list is a Java class or Java interface, we can actually look it up and look what that means. So you can actually look up the source code for anything in Java, right? We can go over here and I can just type in Java source code, and let's look up the source code for a string actually at first, just to kind of show you, right? This is from, now this one from here, this is from OpenJDK, so an open source implementation of Java, right? This is the, and this is the source code for that. Let's go ahead and, yeah, so now I'm going to zoom in, right? And this is the string source code, right? So it says it's in java.lang. Here's all the imports for string. And here's the string declaration. Public final class string. What the heck is final doing up there? Well, final, right, if you remember, means unchangeable when we apply it to a variable. If we apply it to a class, we can kind of take a guess at what that means. And what it means is that if you apply final to a class, that means that you can't create any subclasses. So you cannot inherit from string. You cannot type extended string. Putting final in front of the class prevents you doing extends. And if you do that to a method, by the way, it's the opposite of abstract. Abstract means it's incomplete, my child must inherit it. Final on a method, creating a final method means it's a method your child cannot override. So it's kind of, so final is a great way to keep control of your code. Make sure that nobody can change it. And then notice that it implements three interfaces. It implements a comparable, and then it's got this weird less than sign string greater than. That's a generic. We'll get back to it, but it means you can compare a string to another string. But here, notice it's got comments, right? There's the value, there's its variables, there's its method, there's all the methods for a string, all the constructors first, and then there's all the methods. And notice that actually a lot of this is actually not the code. A lot of this that we're going by is actually documentation for this. this is JavaDoc, and Java uses this automatically to generate the HTML page. Sorry, JavaDoc uses this stuff automatically to generate the HTML pages you so often see when you're going through code. So let's go ahead and take a look at the list source code just to see an idea. We can look at, right, this isn't the source code, but this is the API over here, right? All the methods that it has over here. An interface extends a collection. So interfaces, they don't extend classes. They can extend other interfaces. You can only extend one, though, because it means you're adding on to that interface. And here's all the methods you have to implement in order to be considered a list, right? Over here, that's Arraylist. And here. Right? So here's the JavaDoc, right? You need a method called contains, which will to return true whether or not this list contains that object. Is empty tells you whether or not it's true or whether or not the list has stuff in it, right? So you have all these methods that you need to implement in order to be considered a list, right? All sorts of things. Remove and add are two big ones, but also contains, get, and set, as we'll learn, are really big ones. Okay? All right. So now let's go ahead and see how, okay, so now that we have this idea of a list, how do we make one? Right? Well, what's an array list? So let's go into here, right? Let's go ahead and create, so list L, so list is equal to a new list, and of course you cannot do this because a list is an interface. First thing I have to do is import it from java.util. So we import it. It says, of course, it's an interface, you can't make it. So you got to tell it, how are we implementing this list? Well, the first way we're going to learn to make a list is using the Arraylist class. Okay, so an Arraylist is a list that we implement much in the same way as an array. In fact, we use arrays with array lists. So there's two basic ways we can make lists. The first way is by using an array, by allocating sequential blocks of memory. One cohesive block of memory, and just that's the block of memory we use for our list. And then the other way of making a list is to allocate little bits of memory, small blocks of memory as we need them, and it's scattered all throughout our memory. And each item in the list tells you where to find the next item in the list is in memory, sort of like a scavenger hunt. Okay, those are two ways to build that we'll learn how to implement a list. So with a list, we can do some fun stuff like list.add. So we can add a certain object to this. We can add any item we want. Let's go ahead and start adding integers. 1, list.add 5, list.add 8. And it's actually pretty cool. We can now print out our list over here, and we've added 1, 5, and 8 to this list or array list, right? And this is what it contains. In fact, we can get what item is at index 0 and index 1. So sout list.get 0, sout list.get index 1. It'll give us 1 and 5. What's also cool is that I can add to a specific index. List.add, I want to add 5. We always do the object first. To index, I want to add, let's say, 1000 to index 0. Well, actually, it says the index first. My bad. Index first. And there we go. So you always do the index comes first when there is an index. All right. So now, so we can just add stuff to this list, no problem. Okay. I think I'm getting a warning here, in fact, though. Declare list with type Arraylist. says to do that. I get any more warnings here? I do get warnings here though. You should be getting warnings on your IDE if you're following along with me. It says uncheck call to add E. This is really weird with that E coming up. As a member of a raw type, this is all stuff having to do with generics, which we'll get to very, very shortly. Okay, but this is how you make a list. You can declare an array list. You can declare a list on the left, and then tell it, do you want to do an array list or do you want to do a linked list? Okay, so and now I think the next video is the perfect place to start introducing generics. So we'll do that in the next video, but I'm going to finish up here by showing just how you can do some common operations. So you can get a value at index 0. You can also change out the value at index 0 by using the set. We can replace index 0 with a bunch of 9s. And then we can see, so list. So we added 10,000 to index 0, and then we changed the m at index 0 to 999. Okay, how do we iterate through this thing? Well, we can use the for each loop, but let's work on indices first. For int I is equal to 0, I is less than, and this is going to be, so not list.length, but list.size with parentheses tells you how many items there is in it. For any collection, which is basically, so for every data structure we learn in this class, we don't use length. We use the dot size to tell us how many things are in it. So that gets kind of annoying. Arrays have a dot length, no parentheses. Strings have a dot length with parentheses. And all the other data structures have a dot size with parentheses. Why? Because I suppose the developers of Java just hate students. That's my only guess that I've got for this. So anyway, otherwise it's exactly the same paradigm. And if you want to print out the item at that list, you do list.get I. I'm not going to store it in any variable yet because that's going to open the can of worms into generics, so I don't want to do that quite yet. Now we print out 999, 1, 5, 0, and you can also remove stuff from the list by using .remove, the item at an index. We'll go into more detail about those functions later, but now we have to open the can of worm that is generics and why they're awesome.